Hello, my name is Gavin Fleck, and I'll be presenting for Team 31 as we are walking through DP2 for Bike-LockDown Incorporated. Our group members are Matthew Kalari, Connor Eslich, myself, Gavin Fleck, and Jasmine Mendez. The first step of understanding the whole process of DP2 is to look at our foundational topics. These start with what we've covered in DP1, which start with our mission statement, our customer profile, our use case, our customer needs, and our specifications. So the first thing that we have is our mission statement, which first of all spurred from our problem that we encountered. We found a market for bike locks on the Virginia Tech campus. This is because everywhere you walk on campus, you'll see some sort of bike around. So our mission statement is for us to create an affordable and easy to use and a functional bike lock that people on campus can use. Then we have our customer profile, which pretty straightforward is just our bike riders on campus. We have our use case, which is to be hooked onto a bike rack on campus from the bike. We have our customer needs, which will be covered later, but overall include the functionality and the ease of use of our product. And then we have our specifications, which is how we'd like to move forward with our product. We then have our functional decomposition table, which we can see, or black box method, which starts with our inputs on the left and our outputs on the right. Our inputs on the left include energy and signal. So we first of all need to store our energy for our design, and then we also need to input a signal. The signal will then need to be received from the user of the bike lock. And then after that signal is received from the user, it then needs to send a signal to the energy converter, which will convert the energy stored in a battery, then will be pushed to a servo, which will then turn a servo on, which will give us a movement as an output. The next thing that we have is our concept generation table, which shows us all the ways that we have to modify our design. This allows us to mix and match different subcategories of these functions to make our designs. So the first one we have is power, the second is motor type, then we have our mounting method, we also have our securing hardware, and then we have our unlocking method. So to describe these, our power is how we're going to give energy to our device. So our three options were a battery, it'd be solar powered, or it'd be powered by hand. Then we have our motor type, so how we want it to physically move. This will be done either by a servo, a DC motor, or once again, by hand. The next thing that we need to think about is how are we gonna mount this to the bike? And the four options that we came up with were directly on the frame of the bike, either Velcro, making use of the cup holder, or a clip-on method. The next thing that we have is our securing hardware, which is the physical barrier which keeps the bike locked up. And our three options are a cable, a chain, and a bar. And then we have our unlocking method, which releases our securing hardware. And those four options are remote operated, unlocked by a combination lock, a dial lock, or a key and a lock. We then decided to use the 3-2-1 method to refine our ideas. The purpose of the 3-2-1 method is for all the group members to come up with ideas. So we have 4 total group members, 3 others, that will draw out ideas and give a sketch and a basic outline of what they picture a possible solution to be. And then the 2 in this is each group member is responsible for 2 drawings, and then the 1 is a rotation of review. So after we had all drawn two drawings each, we then swapped with our partners and we gave feedback to one another. To talk about the ideas that we generated, I'll start with Matthew's on the left, and then Connor's, and then mine, and then Jasmine's. So first of all, Matthew's first idea is a bike lock that mounts directly to the bike, and the securing hardware is a chain. This chain will then be pulled by DC motors, which will then can be unlocked and locked by a remote. His second idea clips onto the bike and has a cable, a dial lock, and a servo. Then moving to Connor's ideas, he has one that's attached by Velcro and is a bar lock, which is then hand cranked and unlocked using a combination. Connor's next idea is a cable lock that will be spooled up by a servo and a DC motor and unlocked using a combination, and once again, we'll be using a clip. My first idea is a bar method. It will be attached to the bike, and then it will have two pivots which will allow the bars to swing to the right and to the left, so then when the user walks their bike up to the rack, it can then be easily maneuvered in and the bike can lock. Because the bar is stiff and it's attached to the bike, we need something to allow it to pivot so then it can be actually used. Our next idea was to make use of the cup holder of the bike. That's a feature on bikes that aren't typically used too often, so we figured we could fill that space up and put the bike lock in it. So this one is about the size of a water bottle and will have a cable that can be pulled out and retracted using a servo and then is unlocked using a key. Starting for Jasmine's first idea here, hers is her energy is stored in a solar cell, and then that energy will then be pushed to a servo, which then will activate a cable to then be wound up and unwound, and then can be locked using a key. And this is clipped onto the bike. And Jasmine's second drawing uses the bar method, where it's two automated bars that will essentially start like this, and then when it's been activated by the remote, will open up and then can clamp back around the bike lock or the bike rack in use. So after taking this 3-2-1 method and also the concept generation table, we can combine them and we can make our gallery method. Our gallery method is a poster that we had made, which can then be used to showcase all 8 of our ideas and the paths that they follow. It also shows all of our sub-functions and subcategories within those and what they look like. Moving forward, we have our concept screening, which then takes our customer needs, which have been listed on the left, which is a low profile design, user easy access, it's mountable with secure connection, it's durable and a secure locking mechanism, and it has an indicator for lock activation. After looking at all of these concepts and then comparing them with the selection criteria, we then narrowed it down to 4 more that will move on to the next phase. The 4 that have moved on are the bar and motor, the cup holder idea, the pivoting bar idea, and then the Velcro mounted idea. So then we move a little bit further into a weighted index of screening our concepts. This will then be used to select our final concept. So after looking at the weight of which we believed each customer need / selection criteria was then multiplied by the rating given. And then these percentages times the rating given would then be added up right here as we see down into a final score. After all of these, we have seen that the cup holder bike lock idea was the most successful and satisfied the most customer needs. We then took this a step further and took the simple drawing on the left and transformed it into a CAD model. To simply summarize what we had come up with, we have the shell, which is divided into 3 pieces, which is the upper shell, the middle shell, and the lower shell. The upper shell contains itself and then also the physical lock, in which the key is inserted here and then the cable is inserted in the front. Then we have our middle shell, which includes the cable and the drum. The drum is the cable is spooled around, and the cable will come out of this hole and then eventually, after it's been unwound, will go into the lock here. The drum is what the cable is spooled up on and what the servo is connected to. The lower shell then contains the servo, the Arduino, the battery, the button, and the breadboard in which the servo will be operated in, and the user will be able to press a button which will go into this hole or this hole, which is the same hole, just two different angles. And that will activate the servo to wind it up. The bike lock cable is able just to be pulled out and inserted, and it automatically locks. And then you need a key to unlock, and then you can wind it back up using the button. After this presentation, we have seen that Bike-LockDown Incorporated is even closer to production. We've covered our foundational review, our functional decomposition, our concept generation, our gallery method, and our concept selection. Thank you for listening. This is Bike-LockDown Incorporated.